Oh, Christ.
So for the warm-up, we just worked on some of the properties of exponents, right? We're not going to graph today.
Is this the properties of logic?
Logarithms. Okay, so very similar to the properties of exponents, we have properties of logarithms. We're going to go through and compare the two. I think it'll help you.
Well, what if you didn't understand the property of exponents?
Those?
No, I was thinking sine, cosine, or whatever.
So one property for exponents was that, right? What do we do there?
Add.
Add, right? Okay. There's a very similar property for logarithms.
That's going to be the reciprocal to that, right? Because log is just reciprocal to exponent. Exponential.
You notice the similarity, right? Multiplied.
Yeah. Is that log 2?
Yeah, we'll just use base 2. Okay. Yeah, you got to compare those two. They're slightly different, but kind of have the same thing. You multiply inside a log means you can split and add. Okay. There's one example.
Wait, is
Could
that
that be
2 to
done?
the n power and 2 to the n power? Is that log down to regular n?
This?
Yeah.
Yeah, log 2m plus log 2n. Any numbers you put in here we can apply.
What did it say like that?
If you could, the reason you would do this would be to simplify the logarithm, and it would probably give you a neater solution. Okay, we think. So we'll use this to solve equations. I'm trying to think of an example. It's not coming to me right yet.
Can we just plug in from the district?
Yeah, you could say like log base 2 24. 24 is 8 times 3, and you can split it. So here's one way to use these. Okay, this is 8 times 3, right? Yeah?
Yeah.
So we could do log base 2 8 plus log base 2 3. What's log 2 of 8? What exponent of 2 makes 8? 3. And then this would just be a calculator problem, but there's one way to use it. Okay, we're going to mainly use these in solving equations.
Can we use this in the so that we can like if you would have used 6 and 4, 12 and 2.
Yeah, you could have chosen other numbers, but maybe gets rid of most of it. What about this property of exponents? What?
It's cube. So you can just subtract your x.
Subtract, right? Cube. Okay, well, let's try this. What do you think the property is?
Subtract.
Okay, subtracted. It's just like the one above. Okay, so. Again, various ways to use that. We'll get into some here in a minute. Shut up. How about this one? multiply? Is that what you said? Yep. We multiply. Dave, what do you think we do with the exponent here?
You just multiply it by log.
You're gonna multiply up front. It's kind of this is the one that kind of throws people off.
So you put the n out constant. Okay.
Okay, if there is an exponent in here, you can actually move it out front and multiply. Okay, but it does relate to this property of
Is
exponents.
that log with base 3 to the
X to the n. X to the n. Yep. You can take that exponent and move it out front. They're just arbitrary bases I'm choosing.
No, but like for example, up there, when you put log 2n, n is normal, right? That's not 2n.
So like if we got log.
3 is a base, but,
This is the base, these are the numbers inside the log.
okay, but like if you were to write it at the m and the n right there, those are next, right?
These are regular old numbers.
So on calculator, how would you do the base?
Oh, I can show you that.
So I have a question.
What?
So if we would've plugged in that times where
Yeah.
Yeah.
squared,
Alright, so those are the three main properties. Wait, let me put one more thing up here. If that's true, what do you know about m and n? Yeah, they're equal, right? Yes. Okay, we're having a little chit chat issue here. If this is true, n and m have to be equal, right?
yeah.
You know what that means?
No.
Therefore, the predator's gonna kill you. There.
You say force.
What?
I like that.
I actually use that a lot. I'm lazy.
Okay, so similar property here, if I have log. That means that n is equal to m, right? Yeah. It's kind of common sense, but you do have to make sure it's a stated property for it to work in that. Make sure the bases are always the same, if that's true. Alright, so those are the properties, you'll be using them to solve equations. That's the big part of today. Good?
I like the log.
I hope you think it's easy.
Log.
Because I'm about to make it more difficult than anything else.
How about that?
I don't think there's anything with the true identity.
Yeah,
Dude.
I hate when
I'm listening. Here. 2 cubed is 8, correct? That's why it's 2 cubed is 8. You're trying to find the exponent of 2 that makes it. Alright, let's solve an equation here. There are lots of ways to go about these. Do you have any ideas firsthand?
Move the,
Multiply.
take your second
Fourth.
exponent down in front of log.
Okay, so one property you could use, right, is to move that exponent in front, right? Okay, so that's one option
Oh, wait,
to start.
is that part of the
caution you against doing that right away here, but 164 to the 1/3.
Oh,
It's 4. Okay, there's another way to start. So basically you're looking at here. There's
Yeah,
another option.
That's what I was gonna do.
How are you gonna solve it then? Yeah, this is a good one for turning it into an exponential. Because it helps you see what you have to do. P to the 1/2 equals 4, right? P. So now I can solve exponents, right? How do I get rid of a half exponent?
4 times 4 times 4 is 16 times 4 is 16.
Square.
Yeah.
So 1/2 squared is 1, right? So P equals. Sorry.
I'll wait till this comes
So again, 16 to the 1/2 power is 4. Right? 1/2 is square root. 16 square root of 16 is 4. That's it. So, one way to solve that question for that equation.
Where did the 64 go?
It's the cube root of 64 is 4. So
Can you find that on our calculator?
cube root of 64.
Yeah.
I'll show you how to calculate these on your calculator in a minute. Here's another one. Make that a plus. Okay, log base 4. Alexis and Drew, please stop talking, please. Log base 4, 2x plus 11 equals log base 4 of 5x minus 4.
So here the 5 is that the power of 2x plus 11? Or is that just
That is the number
So that means
in the
that-
log.
That's like the.
Yeah, notice the base is the same here, right? So that means this is true.
How is that true?
The log base is the same.
Oh, the base
Correct.
is the same, and then
Then
imagine.
you know these have to be the same if these are equivalent statements.
Oh.
And then you can solve that linear equation.
Yeah, what is that? The triangle?
That, I don't know what. So 15 equals 3x, right? X equals 5. That's your goal, is to solve for x.
I've
Or
never
you'll
seen
be able to
like that.
What does that say?
What? I don't know what that is.
15 equals what?
How do you get 3? That's a 3.
I don't know, how would we solve it if log, the bases weren't the same?
You would say
You
that's
like the
substitute.
stuff.
It gets a little messy.
Just tell me that doesn't.
That's not gonna happen tonight on homework.
Yeah, it sounded like that.
I'm pretty sure it isn't. But I would have to look to be sure. I don't. want
Triple
to
check.
say off the cuff.
Call me.
Base 11.
You should not have any change of basis here because you don't know
Oh,
the change
those
of
are both
basis.
11? Yeah, me too, I wrote 4. Oh, those are 11.
They are 11s. I've never had by UC using this before. Sorry.
Yeah, I didn't either.
have log 11x plus log 11x plus 1 equals log base 11, 6.
And your x is the exponent, correct?
There is no exponent in this problem.
Well,
So why you guys are thinking exponents? The log base 11 of x is not 11 to the x. Right. Okay, do you notice the bases are all the same, right?
Yeah, so can you just take out the log part, make it look a lot simpler?
We cannot yet. See that addition sign's in the way. Can we deal with that though?
Yeah.
What property are we gonna use? This one right here. See how the bases are the same and they're added? You can multiply. So we end up with log 11 x times x plus 1. You multiply these two items. Equals log base 11, 6. Right? You're good there? We use that addition multiplication property. Now what can we do?
Now you can take away the log.
Now we can eliminate the logs, right?
Yeah.
Can I distribute to like
Yeah.
x squared plus x is 6?
And then, yeah,
Then you just math.
No, it's quadratic. What does it have to equal?
0.
To solve it, right? We have to do 0. Right there.
and then you factor in the x plus 3 and minus q.
Yeah, you can factor that.
And then you get negative 3
This
and
gets this
2.
complicated. I can do everything up until you start it back.
That should be the one.
What are our
I
x
don't know
values
yet.
that make these 0?
Negative 3 and 2. And negative 3 doesn't work.
Why did it make it?
Why not?
Because it doesn't. Oh, wait, no.
Because Damon said so, that's why.
Yeah.
Good answer.
I know. Never mind. Yeah.
You have to check your answers. I did not ask you to do it here because we
So-
don't need to.
So then why do you get a negative 3 and positive 2 when you get a positive 3?
Because you have to,
This has to equal 0. What value of x makes it 0? Well, it's plus 3. What value of 20 makes it 0? Okay. The question from yesterday, we talked about the domain of logarithms, right? The logarithms defined for negative numbers. Or not. Okay, so if you look at the graph of the log, it looks like this, with any negative x values. Okay, so negative 3 is not an answer.
whoa. Any negative is never an
Because
answer.
it's not in the domain of log. So you have to think a little bit sometimes, but negative logarithms, no bueno.
Yeah.
Unless we've shifted the graph to the left, but we haven't. Just be cognizant of that, okay? So the only answer that works is those.
How come because not in domain of
Negative 3 is not in the domain of log,
Oh.
right? There's no negatives out here. Right? Okay. Any questions?
No.
No? Alright. Give those a shot. Bring questions Wednesday. You don't have class Tuesday, so
So no, not
honestly, juniors, something I did not do that I wish I would have done is study more for these tests that matter for your college education.
I agree with
I would wait.
We should.
I would study for SAT this weekend and wait to do this until Monday. Just-
I seriously
That's
felt
advice.
like
You don't
for
have to do that, but
competitiveness.
that's what I would.
I was saying this morning that we should have started taking doing SAT practice as freshmen.
Not a bad idea, actually.
And then Miss Tater tells us to study while giving us that.
You're online, by the way.
She's throwing the stupid. It's okay.
That's okay, she doesn't want, she doesn't care about math.
No, she doesn't. Just be honest.
She doesn't care.
There it is.